Lesson 117 is about direct and inverse variation squared. Now we know about direct and inverse variation already. Direct variation means as one goes up, the other goes up, or maybe as one goes down, the other goes down. And inverse is as one goes up, the other goes down. Direct variation, that uses multiplication, while inverse variation, that has to use division. Now, our first problem says the distance a body falls, so distance a body falls, varies directly, so this is going to be multiplication. We've got our k value, our constant. It varies directly as the square of the time that it falls. So the time, and it has to be the square of the time that it falls. So we've got our equation set up. The distance is equal to our constant of proportionality k times our time t, which has to be squared. Now our question says, if it falls 144 feet in 3 seconds, so 144 is going to be equal to k times 3 squared, and we'll put this in parentheses. How far will it fall in 10 seconds? Well, first thing we need to do is solve for k. So 144 will equal whatever our constant k is times 9. 3 squared is 9. Then we have to say 144 divided by 9 in order to figure out what k is. Well, 9 goes into 14 one time. That's 9 with 5 left over. We bring down our 4. 9 is going to have to go into 54 6 times. So we get 16. K is equal to 16. Now remember, that's not the final answer. That just tells us that our distance will always be equal to 16 times our time squared. And that makes it easy for us to solve this next problem, because it says how far will it fall in 10 seconds. So the distance is going to equal 16 times 10 squared, because the time was 10 seconds. 10 squared is 100, so the distance is going to equal 16 times 100. And 16 times 100 must be 1600, or 1600. And this is measured in feet. So the distance that it will fall in 10 seconds is 1,600 feet. We use that formula d equals k times t squared because this is direct variation squared. And remember, k is our constant that we figure out from the first information given to use to solve the problem with the question that comes after the first piece of information. Let's look at another. The weight of a body on or above the surface of the Earth varies inversely with the square of the distance from the body to the center of the Earth. If a body weighs 10,000 pounds at a distance of 5,000 miles from the center of the Earth, how much would it weigh 50,000 miles from the center of the Earth? So this one, it says it varies inversely. So we must have division. As one thing goes up, the other thing goes down. So the weight of a body is equal to our constant of proportionality k over our distance from the body to the center of the Earth. But it has to be the square of the distance. So distance squared. Now let's fill in our values. The weight of this is 10,000 pounds. And it's equal to k over d squared. The distance is 5,000 miles. So we're going to have to take 5,000 miles and we're going to square it. Now to find our answer, k, here, our constant of proportionality to help us figure out the second part, we need to say 5,000 squared times 10,000 in order to isolate k. Now, 5,000 squared, well, 5,000 squared must be 5 times 5, that's 25. And then we must have 3, well, we're squaring everything, so instead of 3 zeros, we're going to have 6 zeros. So we've got 25 million. And 25 million times 10,000, wow, what a big number. That equals k. Let's do this. 1 times 25 is 25. Times 10 to some power. We have 4 and 6 zeros. So that must be to the 10th power. 25 times 10 to the 10th power. But 25 times 10 to the 10th power, that's not proper scientific notation for k. So let's change that into being 2.5 times 10 to the 11th power. That equals k. Now the part of the question we need to solve is this. How much would it weigh 50,000 miles from the center of the Earth? So we want to know the weight. The weight is equal to k, which is 2.5 times 10 to the 11th power, all over 50,000 miles. And we have to take that 50,000 miles and square it, because we've got d squared here. So 50,000 squared. Well, 50,000 squared, w is now going to be equal to 2.5 times 10 to the 11th power, all over 50,000 times 50,000. Well, in this one, we've got 5 squared, which is 25. So we're going to get 25 times, and then we have, well, we've got 4 zeros here, so we need 8 zeros. So we could write 25 times 10 to the 8th. Now, if you notice carefully here, we had 25 times 10 to the 10th before. If we take the time to revert back to that, even though it's not proper scientific notation, it'll help us to solve the question a little bit more quickly when we're dividing like this. So here we go. We've got 25 times 10 to the 10th divided by 25 times 10 to the 8th. The reason that helps is because 25 divided by 25 is just 1. So w is going to equal 1 times 10 to the, and pardon me, it was 10 to the 8th that we had here. Showing the work is an important step that we need. And having the work shown just below helped me identify that very quickly. 10 to the 10th over 10 to the 8th is 1 over 10 squared. And 10 squared, that must equal 100. So we've got 100 pounds. So the object that's 50,000 miles from the Earth, it would weigh 100 pounds. Key here is when we take that inverse variation, we have division, and then we remember on this part that we need to square it. Our lesson practice will be on page 494. Make sure you've got your notes complete, and I'll see you during our next class.